Hello friends, welcome back to my channel. So today we'll discuss the calibration procedure for particle size analyzer. And in the last video I have already explained about the particle size analyzer, right? So the calibration of particle size analyzer is a critical step in ensuring that the measurement we generate are both accurate and traceable to recognize standards. So friends, my YouTube channel name is Pharma Quality. So please view, like, comment and subscribe my channel. So now first we will discuss the wet dispersion calibration. So this wet dispersion calibration is applicable for the liquid medium sample, right? So first one is the instrument power on and warm up. So first you need to switch on the optical unit and dispersion unit and then let the system warm up for at least 30 minutes or more than that to stabilize laser detector and fluid temperature. So basically this warm up period allows the laser output to reach thermal stability, so the detector to reach consistent sensitivity and the dispersion temperature to equilibrate, right? Now the next one is the optical auto alignment. So for this you need to open the mastersizer software and go to the tools, and there will be the option like align system or align as prompted. So when a measurement cell is inserted, so this option will be appear, and then you need to click on this. So the system align the laser lenses and detectors and retrieves alignment confirmation. So by performing the optical auto alignment, the proper optical alignment ensures that the laser beam is correctly centered and focused on the detector array. So even small misalignment can distort the scattering patterns, which directly affecting the accuracy of size distribution calculations, right? So this is very important step. Now the background measurement, this is also very crucial process into this wet dispersion calibration. So for this, use clean filtered dispersants such as deionized water, right? And then execute a background scan with both red and blue lasers as a part of SOP initialization. So the background scan measures the inherent light scattering from the dispersant and optical components without any particle presence, right? So this baseline is automatically subtracted from the subsequent measurements, which removing the false signals and improving measurement precision. So for this you need to take the deionized water. So now after the background measurements, the equipment will be ready for run the reference standards. So to run the reference standard, we need to use an NIST traceable standard such as polystyrene latex or monodisperse silica beads, right? And to use this will require to sonicate the suspension to disperse it, so that the particle of this standard can be dispersed perfectly. Then load it into the dispersion unit, ensuring that the proper concentration and minimal bubbles, right? So this NIST traceable standards provide a known particle size distribution, because it's a NIST traceable standard, so there will be the known particle size certificate will be there, right? And when you sonicate this polystyrene latex, so this will breaks up agglomerates, ensuring that the only primary particles are measured. So the distribution of those particle after the sonication will be perfectly right, so it will measure that primary those particles. And avoiding bubbles is critical, as air bubbles scatter light in a way that can mimic or mask actual particles. So while you are putting that standard into the equipment, into the hydro unit, then you need to take care about that there should not be the any air bubbles, because the air bubbles will going to be captured by the light, so it will may impact your results, right? And when you will done you have put it those particles into the equipment, then run the verification measurements. So there will be a use a built-in or vendor supplied SOPs such as wet calibration verification or verification latex template. So into the mastersizer 3000 there will be the automated SOP created by the vendor. So you need to take those template and then initiate sample loading until ops cursion reaches approximately 10 to 20%. Then begin the measurements and multiple replicates reading are recommended. Right. So what happened? Vendor SOPs are optimized for the instrument's optical model and ensure consistent settings. And the 10 to 20% obscursion range provides optimal light scattering without multiple scattering effects, which replicate measurement verify the system repeatedly and detect any transient issues during the calibration. Right. So now after completion of the run, you need to evaluate the results. Right. So for this evaluation of result, you need to have a automatically generated a calibration verification report via the software system, which including the standard lot number, date, operator, and measured distribution points. Right. So here we need to extract the DV10, DV50, DV19 from the reports. So the parameters like DV10, DV50 and DV90 represent the particle diameter at which 10%, 50% and 90% of the sample volume is comprised of smaller particles respectively, right? So these three parameters we need to cross check with the standard certificates. So again, like as I explained, you need to confirm that they fall within the certified range on the standard certificates. So comparing these values against this certified range ensures the instrument is performing within its validity accuracy limits, right, as defined by NIST traceable standard, right? So now as an example, we'll discuss the acceptance criteria for wet dispersion, that is for hydro units, right? So here I am explaining, this is just for an example. However, there may be the different sizes as per the actual particle size which is present into the NIST traceable standards. So there that may be differ. So let's take example for the NIST traceable polystyrene latex for 60 micron standards, right? So here you can see, so DV10 parameter should be falls within the limit of 55 to 57 micron, right? And DV50 particle size should be 59 to 61 micron, and for DV90 parameters this should be the 63 to 65 micron, and the span should be the less than or equal to zero point 0.4, and residuals should be less than 2% and obscursion 10 to 20%, and the reproducibility, that is RSD, that should be the less than or equal to 1% for DV50 over 3 runs, right? So this is the parameters, and against these parameters there is a acceptance criteria. So this is again this will be depend upon the certificate. So based on that certificate, there will be the your results should be made, right? So now the second one is the dry dispersion calibration, which is used for dry materials. So first step is instrument warm up and software system readiness. So power on the mastersizer software system, optical unit and LOS units, and allow 30 minutes warm up for optical and pneumatic stability, right? And then the next step will be the cell insertions, which triggers the auto alignment. So here you need to insert the dry cell and close the LOS lid. Then the software system aligns the optics automatically prior to the background measurements. So basically dry dispersion uses a direct optical path without liquid, which making accurate laser alignment critical, right? So auto alignment ensure that the beam passes precisely through the center of the measurement zone, reducing scattering artiface from misalignment, right? Then start the background scan using red laser as a part of SOP. Then the next step will be the load the reference standard. So here we need to load the NIST traceable dry standard example PSL powder, that is polystyrene latex powder, into the LOS hopper, and here you need to use the applicable venturi, that is standard or high energy, right? And then adjust hopper flow rate manually and set initial air pressure, for example 0.1 to 4 bar depending on the sample, by a pressure titration, right? So now the next step is pressure titration series. So here you need to perform measurement at multiple air pressure, for example 0 0.1, 0 0.5, 1, 2, 3, 4 bar, right? So replicating at each pressure to assess segregation or inadequate dispersion. So by running the same sample at gradually increasing pressure, you can determine the point at which particle agglomerate are fully broken apart without fracturing the actual particles, right? So the next step will be comparison with wet baseline. So here we need to compare dry calibration measurement, especially for the DV50 parameters, against the results from a validated wet dispersion of the same sample or standard, right? So matching the DV50 between dry and wet modes ensure that dry dispersion parameters are optimal for accuracy. So that is the reason we need to compare this dry with the wet baseline. Now identify the pressure level where dry results best match wet. If needed, switch to high energy venturi for cohesive agglomerated powders, right? If dry results are larger than wet, the powder may still be agglomerated if small particles are likely breaking apart. So adjusting to the pressure where sizes aligns confirm optical dispersion, and high energy venturi may be required for powder with strong cohesive forces or electrostatic attractions, right? So now the final verification run. So at selected optimal air pressure, perform replicate measurement until obscuration is within 1 to 10%. So staying within 1 to 10% obscuration ensures a good signal to noise ratio without exceeding the optical system linear response range, right? So accept the calibration if dry DV50 DV10, DV50, DV90 values are consistent with those from the West standard within tolerance limits. So DV10, DV50, DV90 are key percentile points describing particle size distribution. So the agreement with the wet baseline confirms both dispersion efficiency and size measurement are accurate, right? Now they use the AROS starter sample SOP template to generate a full calibration record. So there will be the auto template, which with the help of that template you can generate the full report, right? So now here we'll discuss the example for the acceptance criteria of dry dispersion. So while using certified dry standard like glass beads or PSL dry powder. So the parameters such as DV10, that the acceptance range 55 to 57 micron, and the result should be matched with the wet results within plus minus 5%, and for DV50 it should be 58 to 62 micron and match certified of wet baseline DV50. For DV19 it will be 63 to 67 micron, so it should be the consistent with wet profile, and the span value less than or equal to 0.5. So slightly higher span is acceptable into the dry mode, right? And reproducibility, that is RSD less than 2% or equal to 2% for DV50 over 3 to 5 runs, and higher variability allowed than wet mode here for the reproducibility. So the obscursion is 1 to 10%. So keep below 10% to avoid multiple scattering. So it is the ideal practice to keep below 10% for the obscursion. And the pressure titration. So the acceptance range, identify the optical pressure where DV50 aligns with wet dispersion. So here we need to ensure that the full dispersion without particle breakage, right? So this is again just an example. We need to uh, you know go with the vendor certificates and their instructions to check the acceptance range for the dry and wet dispersion, right? So here are couple of conclusion for this calibration. So always refer to the Malvern certificate of analysis that comes with the calibration standard, and mostly the vendor will help you to perform the calibration activities. If the internal SMEs which who are very expert into this Malvern, then they can perform the calibration activities, because this calibration is very crucial and very critical. So there is a handling should be the proper, right? And then document the DV10, DV50, DV19 span and residual, and ensure that they fall within the defined range with respect to the certificate of analysis, right? So friends, this is all about the calibration of wet and dry dispersion method for the particle size analyzer. Thank you.